Good morning.
Good morning, sir.
Okay. Any doubts in the last classes, please let us know. So I hope you have done up to sanity checks.
Yes.
Any doubts in the previous classes? Yes, any doubts? Still people are joining. Okay, we'll wait for another 2 more minutes. Any doubts in that sanity checks and data preparation?
Sir, check library is also a command, I think so.
Yeah.
I have read the blogs in that it's given check command, check STC, check netlist.
Yeah, check library is also command. So you need to give get underscore libs, SAED 32 HVT, whatever it is. So report underscore library, view the information about the reference library that is used for viewing the information about the reference library. Report underscore lib. Did you do that?
Yes, sir.
Okay. So mainly we see check netlist, check timing, and check design only. This is to view your libraries, information about the reference libraries. So I hope anybody has any doubts in that. Everybody has done sanity checks. Can you just show me the reports, Vinay? Can you show me your reports?
Sir, just a minute.
Yeah. So that we'll start floor planning. Before that, you need so many informations in that. Sanity checks and data preparation should be done. So I hope everybody has done up to data preparation. Anybody has not done up to that, please let me know and share your screen. I will help you because it's a continuous process. See, there is something known as multi-core, or triple MC, multi-mode, multi-corner data preparation also. That is not so necessary to you, but I'll give introduction to that. Okay. Yes. Okay. Fine. Good. See, everybody open your liblef and netlist file and keep it so that they will be useful for you to see what's happening in the floor planning also. Liblef, okay, and your netlist.
Sir, I have reported.
Yeah, show me those timing reports, no? Open that file.
Yes.
Anybody has any doubts in the previous classes? Please let me know before I start with the floor planning. Before that, you have any doubts in that PVT corners or anything? Multi-mode, multi-corners, let me know. See, generally in industry, they use multi-mode, multi-corner file, okay? I'll just show you what is that. When time permits, I'll do that also. So what are these known as? What are these warnings known as?
These are the false paths.
Okay, fine. So you're given something somewhere false path in the design. There is a false path
Yes, in SDC.
in SDC. Okay. So before going into the floor planning, so you need some data. What is the data you need? So there was some discussion in the morning, right? Let me know what are the things you need before going to floor planning. Yes, guys, I need some answers here. What is floor planning actually? Yes.
Place in input output ports, macros, and the modules.
Okay. So before this, we have done sanity checks, right? Yes or no?
Yes,
So
sir.
how does
Yes,
that
sir.
sanity checks help you in building a floor plan? That's what I'm expecting answer from you. How does? Okay, I'll share my screen. 1 minute. You keep your sharing as it is. Okay, can you see my screen?
Yes, sir.
Okay, fine. So if you see, so this is where we are now. Okay. Partitioning and floor planning. So today, Utkarsh has explained you what is all about partitioning and floor planning, right? Okay, so we have seen sanity checks. So can anybody tell me what we have done up to now? Data preparation and sanity checks, right? So what did we do in data preparation actually?
We collect all the files
Collect
All
required.
the input files.
All input files.
Right, so that's what is your data preparation, right? So I hope everybody has done this, right?
Yes, sir.
Okay, so what are the things you need for data preparation?
.lib.
.lib, right? So it
Postgres.
has functional information, okay, timing information, and
Area.
Or
power
information.
information, area information of what?
Standard cells.
Standard
Standard
cells.
cells.
Cells,
Macros.
nets, IOs, right? Good. So this is what is the input what we have given, right? Then
.tf.
SDC.
Netlist files.
we'll first go with library team inputs. .left. So what does this .left contain? Please open
Physical
that
information.
open that left and netlist and lib file also and keep it because that will be useful for you now. Because I will show you some nets, show you some tracks, show you some metals. That information is available in these files, right? So what is this dot left all about? What does this dot left has?
Physical
Coordinate
information.
locations.
Yeah, it has physical.
Physical information of standard cells and
Okay,
macros.
physical information of
Standard cells.
Standard cells and macros.
standard cells, macros, and everything, whatever is there above, right? Is that clear?
Yes, sir.
So then this comes from your library P. Same way now. So next input.
TLU plus.
Okay, we will see about foundry inputs. Okay, what are those?
TLU plus and technology.
.tf file.
.tf, that is nothing but tech file, technology file. So what does this file has all about?
Metal layer information. Color.
Metal layer informations, all about layer information. Layer information about
Metals.
metals. Good. So vias, whatever it is. Good. So then all the information is present in this vias, so many other things, right? Then you have TLU plus file or RC extraction file, right? So what information it has?
So are you writing?
Yeah, I'm writing.
So your screen is not visible. It's Vinay's.
Vinay's screen we have.
Oh, Vinay, you stop
View
sharing,
options.
Yes.
Now we can see.
Yeah, I think, okay. So both the screens you can see, I think, right?
So we can see by selecting
Yes,
the
sir.
options.
Yeah, you have some options you can see, because that screen also I need now. Next, okay. TLU plus file has what information?
The delays.
It's also known as RC tech file.
Net delay.
Sorry. What is that? Delays. It's all
Parasitic.
about resistance, parasitic, right?
Parasitic. Yes.
Parasitic information, RC, electrical properties, so on and all those things. So this comes from your foundry. So this is what is available with the foundry. So I need to use that and build my design, right? So then finally, if you come to the design team, you have two more inputs. That is what is netlist. Okay. Gate level netlist. So what does this has?
Logical connectivity of the cells.
Okay, logical connections. Okay, logical connections. So you got this from synthesis, right? So same way you have .sdc, design constraints, synopsis design constraints or system design constraints, whatever it is. So it has timing information, right? About clocks, transition, right? Load, yes or no? So a lot of information is present in this. So this, by using this, we have done data preparation. Up to that, anybody has any doubts? Please let me know. Yes. Everybody has done data preparation?
Sir,
Yeah.
sir, yeah, means that day I saved all my reports, but today they are not here.
Again, you save. Don't worry.
No, one day earlier also for the data preparation of the DTMF if I created, but that was also gone. The next day I opened ICC2.
That will not happen, no? I think where you have opened, where you have closed, check it. Okay. That will be available. Check it once again today. We'll see.
Saved it, but today it's not there.
Okay. We will check that. Where you have saved in that November something I said you, right? To use that folder, new folder you create and do it. Did you do that?
Oh, okay. Sorry, let me check.
I know. No problem, Vaishnavi. Okay. Any other doubts, guys, up to this? So next we have done sanity checks, right?
Yes, sir.
Sanity checks. So what we have done, check design. Yeah. So what are the sanity checks you have done?
Check
Check-
design. Check
Check
netlist.
netlist, check timing.
Okay, you're done check underscore netlist. So what does this do? Check underscore netlist. So this is all about netlist checks, right? Between your netlist and library. Is that clear?
Yes, sir.
So then we have done check underscore timing also. So what do you check here? Check underscore timing. You check SDC, you check netlist versus SDC, right? Yes or no? Is this clear?
Yes.
So then you can do report underscore timing. You will get reports and all the things. You can do that. So then we have done something check underscore design also something, right? What is that? Report underscore design mismatch, right?
Report underscore
sir.
design, sir.
So previously it was check underscore design. I don't know why they have changed. Report underscore design underscore mismatch. Okay. And we have used something report underscore design and all, right?
Yes, sir.
So design all, something all we have used. So what is this all about check underscore design? What does this do is it shows you all about design statistics, right? And also it shows you if you have some multi-driven nets. Yes or no? Then what are the things you have gone through that when you type that command? So then uniqueness of modules. It will show you what are the uniqueness of the modules. Okay. Then floating input pins and output ports also shown here. Yes or no? Is this clear, guys?
Yes, sir.
Okay, these are the information you got. And in the check timing, what is the information you got? So it will check for port consistency, right? Port consistency between SDC and your netlist. This is what it is doing, check underscore timing, right? So unconstrained input and output ports. So if the delays are missing, that also it checks. So unconstrained also it will throw. Okay, unconstrained inputs or outputs, something like that. It will tell no drive or no load like that. Yes or no, guys?
False paths.
False paths. Okay, false paths. So in this design, you have seen only false path, but in some other designs, you may get these things also. Okay, or you may get like clock not found. Yes or no? Getting things. So there
Yes.
are some combinational loops like this. So many errors you can be getting from this. Okay, check underscore timing, check underscore design and netlist. So these are the sanity checks we have done. So any doubts up to this? Please let me know if you have any doubts up to this. Yeah, this is what we have done in the last class. Please let me know if you have any doubts. Everybody has done up to this?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, now before going to floor plan, okay, you should have done these things. Okay, that is very important. Okay, again we will do that. What is check netlist and all the things. So just open your putty now. Okay, everybody has opened that. So you can go to that folder, whatever we have created, November 3 data preparation. Everybody has that folder?
Yes, sir.
Yes, sir.
Okay. See, before that, I'll show you one more thing. Okay, just listen. Okay, I'll do it later whenever we get time. It's not necessary to you. It's for experienced people what they do. Okay, I'll just. Yes, anybody has any doubts in that this thing, please let me know. Yeah. So if you see in the previous class, we have done data preparation, right? So that data preparation is done without using this MCML.pcl. We didn't use this, right?
Yes, sir.
Okay, see, that is all about in-depth concepts. Okay, I'll teach you later about those things. Yeah. Guys, are you able to hear me?
Yes, sir.
Yeah. So this file, you can see it resembles same as what we have done. So you can see this is the first command is used to invoke the tools NDM. NDM is nothing but lib and left. Then technology file also we have invoked. We have created something like lib_dtmf_lib. So then we have read the Verilog. This is what is my code, and then current design, then link. Everything is same, right? Did you find anything different in this script?
Source scripts, MCM.
MCML, right? So see, what is this? I mean, these are advanced concepts. So as a fresher, I don't think you need, but we have explained that. I'll still explain something for that before floor planning. So what I'll do here is I'll just open that MCML also to you. Okay. So what is this all about? MCMM.tcl. Multi-mode, multi-corner. So what is multi-mode, multi-corner? Do you have any idea? Yeah. These concepts were explained by Utkarsh, right?
Multi-VT, using multi-VT cells.
Using multi-VT cells. Good. So you have some idea about that. So you can see this file is all about your multi-mode, multi-corner. So you can see here. So first, whatever corners are there, I'll remove whatever modes, scenarios. I'm removing all those things, and I am creating some corner which is slow and fast. Okay. Then I'll read some parasitics. Okay. Then I will do set parasitics, then set parasitics. Then I'll create a mode. Okay. There are different modes. I'll just explain them today. Don't worry. Then current scenario, functional slow. I can read SDC. SDC can be same or different. So I'm creating basically two modes here. What are those two modes here?
Fast and slow.
Slow and fast. So what do you mean by this? What do you mean by this? Why I need to create slow and fast? See, I'm creating worst and best case here. So if your tool, if your design works for worst and best, it will work for all other cases, right?
Yes, sir.
Yes or no? See, if you are designing a chip, if it is working in Bangalore, it should work in some cold countries also, like -40 degrees or something like that, right? Yes or no, guys? Are you
Yes,
able to
sir.
hear me?
Yes, sir.
So this I'll just explain you. This we will do it later. But today, as floor plan has started, that also I'll explain to you. Before that, I'll just spend some time on this multi-mode, multi-corners. Okay. Yes.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So now I need what is this all about? Multi-mode, multi-corner. What do you understand from that? What is that PVT? So all those details I need now. I'll ask one by one and we will see what you know about that. Okay, I'll go to my PPTs. Okay, see why I'm showing this to you is, so please understand, in the companies they use multi-mode, multi-corners, okay, while doing data preparation itself. So they will invoke this so that your tool, that is your design, should work for worst case and best case. So if it works for worst case and best case, it will work for all other middle values, right? Yes or no?
Yes,
Yes,
sir.
sir.
That is what is all about this. Nothing is there in this except that. So we are creating some corners which is slow and fast. And you know, this is what is parasitic. I am taking max and min. Okay, then see for the parasitics, I have given fast. So minimum is given for fast and maximum is given for slow. Okay. Is that clear, guys? Getting things?
Yes.
Then I'm
Yes.
creating some modes and I'm creating corner and some functional fast and slow, something like this. What is this functional? What are the things? Modes, corners, we'll see now. I'll explain completely about that and we will see this later. Okay. Okay, fine. So now I'll just explain. So what is that PVT is all about? These things you need to know. Very important. If you don't know this, again, it will become mess in floor planning, power planning, and all the things. So what is PVT all about?
Process voltage.
voltage temperature.
Process like slow, fast, right? Typical, okay, typical, then voltage, then temperature. So what is this slow, fast, and typical? What do you mean by this process actually? Yes.
It is
They
based
occur,
on channel length, mobility, and gate oxide.
they occur during manufacturing process.
See, this is what is about deviation in attributes, okay, during manufacturing process. Okay, for example, if you take in the manufacturing process, the doping may vary, right?
Yes, sir.
So, see, this is nothing but deviation of attributes. Deviation of attributes. Attributes means there are so many things, right? Doping,
Thickness,
oxide thickness, and attributes of transistors.
transistor.
Okay, during fabrication, that's what is all about process. So I'm doing some process, if deviates something from that, it is known as process. Okay, yes or no? So you can see what are the effects of this process variation. What are the effects? What happens if something deviates?
Threshold voltage is affected.
So like oxide thickness varies. So what does this affects actually? If oxide thickness varies, what happens?
Threshold voltage varies.
Threshold voltage varies, right? Yes or no? Please understand, this is all about process, slow, fast, and typical. Okay. Then there are some more effects
Doping.
also. Dopant and mobility variations also. Okay. What do you mean by dopants? What do you mean by mobility?
Doping means we are adding some implants like in
Right,
our
we are adding some doping, P implant and N implants, right? Yes or no?
Yes, sir.
So that may be also vary due to process, due to some manufacturing process, right? So you cannot tell that doping is perfectly done. Like you will be doing lightly doped, heavily doped, yes or no, N plus, P plus, and so on. So this variation also can be there due to the process. Yes or no, guys? Then you have something known as your transistor width and length also varies. Yes or no?
Yes, sir.
So then RC will also vary. So these are the effects due to this process, right? Yes or no, guys?
Yes, sir.
These are the effects. Now, how does this affects your delay? That we will see now. Okay. So I'll take my x-axis as my process, and I'll take my y-axis as my delay. Okay. So somebody was explaining in the last class. What happens now? I'll take this as slow, typical, and this as fast. I'll go because slow will be always nearer to 0, and increasing fast will be like this. Now, what happens to the process delay when it is slow? If the process is slow, why it is high? My question is that. Simply don't tell me some answer. I need proof for that. Yes.
Because the current is less, so it will take
How
more.
current is less? How current is less?
Threshold voltage is very high.
Threshold voltage is very high. Why threshold voltage is high?
Oxide thickness is very
Right. So due to these effects, your V threshold
Very large.
changes. Right? Changes. It is less or more, I don't know. So Vth changes due to this above conditions, right? So what do you mean by Vth? It is the minimum voltage required to trigger the MOSFET, right? Yes or no?
Yes, sir.
Yes, sir.
So there is some ID expression to us. What is that ID expression? 1 by
Half
2.
mu and C ox WL.
Yes.
Mu
See,
n.
I need derivation for this for the next class. Take it as assignment.
Yes, sir.
Okay. You need to derive this. How did you get this? I need to know. Okay. I'll ask you to share your screen to show me this. Soft copy of this should be there with you. Okay. Write it. Keep it with you. So how did you get this? What is the expression for ID for saturation, linear region, cutoff region, everything it should be there. And what all the things depends on what things your ID depends. Okay. Okay. So Cnox, then W by L, it is VGS minus Vth whole square, right?
Yes, sir.
So now if you see here, delay increases and decreases with respect to current, right?
Sir.
Yes or no? So as delay increases or decreases with respect to current only. Okay. So now delay decreases as current increases, right?
Yes, sir.
And your delay increases as your current
Yes.
decreases. So how do you tell this? How did I do this? How did I give this statement? How delay is related to current?
Drive strength.
Drive strength, right? It depends upon the capacitor. So input transition and output load. So if current is less, it takes more time to charge, right?
Yes, sir.
So delay increases. And if current is more, it takes less time to charge. So the propagation will be less. Yes or no? So now if it is slow, if it is slow, delay will be worst. Why delay is worst? Why delay is worst? Why delay is worst?
Less current.
Less current, right? Because there are effects. These are the effects due to process. In this process, there are something like slow, fast, and TT. See, this comes from manufacturing defects. Getting things? So your delay will be worst in this case. As so on, if you take typical, your delay improves. So on, if you take fast, your delay decreases. Getting things? So if you want to go for if your design is timing related, then you need to go for what type of cells? Fast. So these cannot be avoided. This is manufacturing defects. It will be there in every process, every technology nodes. Is that clear, guys?
Yes, sir.
Any doubts here? Very, very important concepts. These things only they will ask in the interview to you, not show design something and show something inside and all. They don't ask you. Is that clear?
Yes, sir.
Okay, next. What about V? What is this V all about?
Voltage.
What voltage?
Supply voltage.
Supply voltage, right?
Yes, sir.
This is supply voltage. Okay. So what is the temperature? It can be minimum, it can be maximum. So minimum temperature, whatever we have seen in our lib file is minus 40 degrees to
Minus
plus
120.
125 degrees. This is the range we have seen, right? Yes or no? Extreme cold, extreme hot. These are the things what we can come across in our world also, right? So these are the temperature things. So now, any doubts about process? So please open lib file and check each process also. That is what is your assignment in the previous sections. I said you check everything. What is the difference between SS? What is the difference between FF? What is the difference between TT? Is it clear, guys? Okay, fine. We'll go to voltage now. What happens to the delay with respect to voltage? We'll see. Okay. See why I'm explaining this. This is all about multi-mode, multi-corner. Okay. So now what happens to voltage? Okay, what happens to voltage? What happens to delay?
Low voltage, high delay.
Low voltage, high delay. Okay, how does this voltage vary in the chip? Guys, I need some answers here. Sudhir.
Yes, sir.
Yes, Sudhir. What is your voltage? PVT. In PVT, what is this V and how does this affect your delay? Can you tell me that?
With delay increases, the voltage will decreases.
See, first there should be some variation in voltage, right?
Yes, sir. By
So how does this variation comes? From where this
by
variation come
process.
from? By?
Effects in the oxide thickness, oxide varies.
No, that is all about process, Mr. Sudhir.
Okay, sir.
That is all about process. I'm not talking about process now.
RC by RC, sir.
What
By
RC?
resistance and the capacitance in the wire.
So please understand, you will be doing some floor planning now, right?
Yes, sir.
For example, your input pin is somewhere here. Okay. One cell is placed here and another cell is placed here. So now this input pin is connected to this. Input pin is connected to this. Okay. Yes or no?
Yes, sir.
Now,
Sir.
for example, think that this is your supply voltage, Vs. Okay, you are giving supply voltage to this some AND cell or something, anything, macro, whatever it may be, standard cells. So is the voltage reaching to this first cell and the second cell is same?
No, sir.
No, sir.
No, sir.
No, it will be different. Why it is different? That is what is known
Yes.
as your corners. Yeah.
Corner.
So it varies due to
IR drop.
IR drop. IR drop of what?
Wires.
Nets
Wires,
and
sir.
metals.
Wires, right? Wires are nothing but your metals. Metal stack we will be using, right? Yes or no? That layers we have seen already in the .tex file. So what is
Yes,
the
sir.
thickness? What is the width? What is the resistance? So that's the reason I said you to open .tex file also. .tf. Open all the three files. Lib, any one lib you open, tech, netlist. We will see when you what are the information which is useful for us in the floor planning also. Okay. So due to this IR drop, what happens now?
Voltage.
Voltage.
Voltage will
Voltage
changes.
varies, right? Voltage varies. That means it will vary from between some maximum. I'll take, for example, 1.1 volts to some 0.9 volts, something like this. Okay. Is this clear?
Yes, sir.
Yes, sir.
Yes or no? See, please understand the voltage not only decreases, sometimes voltage increases also. How does this happen? How does this happen in the
Due to parasitics.
due to parasitic? See, don't tell parasitic. Parasitic means you have R, L, and C, right? If it is R, voltage will not increase.
Due to
Due to
induction.
C.
Inductance,
Due
sir.
to some noise caused by the inductance. Please understand where E is equals to L di by dt. Yes or no?
Yes, sir.
This is clear. So due to some inductance effect, there will be energy which is stored. So due to that energy stored, sometimes voltage increases also. For example, the typical voltage is 1 volt, but it is going to 1.1, it is decreasing 0.9, some cases. Some cases it will increase, some cases it will decrease. This is what is known as voltage drop and shoot up. Getting things?
Yes, sir.
Yes or no, guys? So if you take capacitor, see, inductor which is used to limit rate of change of current, but it stores energy in the form of magnetic field. Due to that, there will be some more energy, right? That's the reason it shoots up. So now if you see here, with this delay, with this RLC delay, with these elements, there is a delay, right? So with
Yes, sir.
this delay, your current also changes. Yes or no?
Yes, sir.
So as voltage changes, current should change, right? Because V is equals to I into R.
R.
Yes or no? Now I'll draw the what is that graph for this also, so that you should understand, so that you should not forget in your lifetime. So what is this x-axis? It's a voltage. Okay. Voltage. Now you understood voltage will decrease and increase, right? How does that happen? Due to some parasitics. Is that clear?
Sir.
Yes, sir.
So now you have some worst case, you have something known as nominal, and you have something known as less. Yes or no? Sorry, best, not less, best, worst, and typical, right? So now as voltage is less, what happens now? As voltage is less, what happens to delay?
More.
Worst. More delay.
Worst.
Worst.
More delay.
More delay, right? So voltage is decreasing. As voltage, supply voltage is decreasing. For example, if you take inverter like this, I'll take a PMOS, I'll take NMOS. Okay, this is what is my gate, this is what is my supply voltage, right? Yes or no?
Yes, sir.
So for example, this is what is the capacitor now. Okay. So when PMOS is on, your capacitor charges. This voltage itself is decreasing now. If the supply voltage itself is less, what happens to delay? It should be more, right?
Yes.
So that is the reason your delay is more. Worst. Then it is nominal. Then it is, so if you take this, this becomes your slow, this becomes your typical, this becomes your fast. Is this clear? So please understand, voltage is the supply voltage, not threshold voltage. Any doubts here? Any doubts, guys? Any doubt? Are you able
Sir,
to hear
along
me?
with RC, we will have inductance also.
So inductance is very negligible, but it will be there. Whenever you take about your supply, for example, if you go back to your basics, I'll just show you some basics. See, how do you get supply generally? From a transformer, right?
Yes, sir.
From transformer, you have something known as rectifier, something like this. AC, this is your DC, then you get like this. Yes or no?
Yes, sir.
Yes, sir.
So here there is inductance.
Yes, sir.
That effect should be there in this. Even if you take rectifier also, you have some filters inside. L and C, you have a bridge rectifier like this. Yes or no? You have a
PLC
bridge
filter.
rectifier. Okay, this bridge rectifier is connected to your supply. Then you have some filters like this, L and C. Yes or no?
Yes, sir.
Yes, sir.
So due to this also, there will be some inductance, which is parasitic. Okay. Yes or no, guys?
Yes,
Yes,
sir.
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 So due to this effects, there will be voltage drop or voltage bounce. Okay, both are disadvantage to us. So these are the variations. This will happen. That's the reason we have designed everything in the lib, right? Yes or no? We have slow TT. You have seen 0.9 volts, right? You have seen 1.6 volts. Yes or no?
Yes,
You have
Yes,
seen
sir.
0.75. You have seen slow. You have seen fast. You have seen typical. You have seen many things. You have seen some power gating cells also. You have seen something like ULVL. What are those ULVL and all the things?
ultra low voltage.
Yes, they are nothing but your level shifters, right?
Yes, sir.
Yes, sir.
So these are the things. The library is the heart of the thing. If you don't select proper libraries, your design is worst. You are worst engineer. That's it. So they need best or worst?
Best.
Best.
Best, right? So these are the things you need to take care before going to the design. Sanity checks are very, very important. Okay. Then that's it all about your voltage. Any doubts up to this? Please let me know. I'm seeing you people struggle in this concept so many times in the class. You tell some answers and you don't know how.
Yes, sir.
Okay. Now it is clear.
Yes, sir.
Yeah, it clear.
Yeah. Now what about see,
Temperature.
Temperature.
voltage increases now. As voltage increases, this current will be fast, right?
Yes.
Yes,
As
sir.
current is fast, what happens to delay?
Less.
Decreases.
Decreases. See, that's how your delay depends upon the source voltage also. Okay, that means you cannot connect wherever you want. This is very important during floor planning also. See, if your macro is connected to this source, you can place the macro here, not here. If macro pin is connected to this, so there is a lot of difference in these two connections, right?
Yes, sir.
Yes, sir.
Which is better,
Near
Here.
the
first
source.
one or second one?
First.
First one.
First one is better, right? Yes or no? So before going to floor planning, you need to understand all these concepts because you will be placing the macros, you will be placing the pins, and you will be fixing the pins. Once it is done, you are not going to change anything in the further process. Getting things?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Floor planning looks very easy and very simple, but that is the heart of the design. If you don't do better floor planning, everything will be gone. Your congestion will be more. Finally, your timing will be violations will be there, and you need to reduce these violations. You need to add some more cells and all the things. Area increases. So many things will affect. Is that clear, guys?
Yes, sir.
Yes, sir.
Very good. So now see again, there are something concepts like multi voltages in the cell also. That is different again. For that we use some low power synthesis. Okay. These are in-depth concepts. Okay, you try to understand basics first. Okay, next. What about your temperature? What about temperature?
Sir, it depends on the technology nodes which we are using.
So if you take temperature, okay, as temperature increases, how does this temperature increase? Can anybody tell me how does this temperature increase?
If you give some continuous voltage, then it may get heat up. The cells may get heat.
So how
Heated.
does that cells get heat up?
More number of current.
More number of current. Eh?
No, sir, more value of current, sir.
More value of current, magnitude of current. Please use these words. You are engineers, not number and all. Okay, magnitude of current. So how does this magnitude vary now? How does this magnitude vary?
The mobility of the
With
electron.
threshold voltage and supply
Mobility,
voltage.
threshold voltage, supply voltage. There are so many reasons for this, right?
Yes,
So
sir.
that means your temperature, there is temperature in the cell as well as there is the temperature in the chip as well as, right?
Yes, sir.
So generally it is with respect to the junction temperature, because that's where your current flows. That's where your current starts flowing from drain to source, right? Yes or no?
Yes.
So I'm not talking about your ambient temperature. I'm talking about junction temperature. Due to current flow, there is I square R. Due to this I square R, there is heat, right?
Sir.
Yes, sir.
Yes, good. So now, due to this, what happens to delay? How delay is related to temperature? That's what is my question. As temperature increases, what is
Delay.
increasing? See how temperature is increasing. It is increasing due to resistance,
Higher.
right? So current
sir.
may be same, resistance may be different, right? Yes or no?
Yes, sir.
As because current we have seen already, that depends upon some other factors. If resistance is more, then the temperature, power dissipation will be more. Yes or no?
Yes.
So therefore, your delay increases now. Yes or no? Because I'm adding some resistance. Adding resistance means I'm blocking something, right? Guys, are you able to understand?
Yes, sir.
Yes, sir.
So as temperature increases, your delay increases. So if I take my x-axis as my temperature, some minimum temperature, some optimal temperature, and maximum temperature I'll take. This is what is all about delay, right? Then worst delay, nominal delay, and best delay. Okay. So now if temperature is minimum, what happens now?
Best.
Best. Okay, see this is a general case. Please understand, general case means below 65 nanometer. Okay, see even today some analog design is done in 180 nanometer and 90 nanometer, some analog cells. Is that clear?
Yes, sir.
Texas analog devices, they didn't go still into some 7 nanometer and all. The analog design is done in 90 nanometer, greater than 65 nanometer. So you need to know this concept. So in this case only, the delay will be increasing as temperature increases. So that means if temperature is minimum, so you have seen some cells 0 to 125 degrees, right?
Yes, sir.
Huh? Yes or no?
Yes, sir.
That is what is the cells now, minimum temperature, maximum temperature. So as temperature is minimum, your delay will be minimum. Then as so it increases like this. Any doubts here? Anybody has any doubts up to this?
No, sir.
Yes. So now if you see, there is something known as temperature inversion also. Somebody was explaining that. What is that temperature inversion?
Threshold voltage dominates.
Threshold voltage dominates. Okay, something if you tell like this, Sudhir should understand and I should understand, right? So how does this happen? Who is that? Vaishnavi, right?
Deepika.
Deepika, yeah, Deepika. Geetika, sorry. Tell me, Geetika, how does this happen, Geetika?
The threshold voltage is a function of temperature here.
How Deepika? I said, see, I didn't tell anything in a fluke here. I have related everything, right? Yes or no?
Yes, sir.
Yes, sir.
It makes sense. You are telling that temperature is with temperature there is some effect with respect to threshold voltage. How? How, Deepika? Please
Sir,
understand. Yeah.
I read some equation.
You cannot read. If you read, you analyze that. Okay. So what is this temperature inversion? See, generally, delay depends upon what? Generally, delay depends upon output capacitance and
Input transition.
input transition. That's nothing but your current, right? Driving current. Yes or no?
Yes, sir.
So that means I can write your delay is directly proportional to your C out,
Yes, sir.
and your delay is
Inversely
inversely proportional
proportional
to
to ID. Inversely proportional to ID.
ID. How? Because you know that okay, somebody mute. I increases as current increases, delay will be less.
Decreasing.
As current decreases, delay will be more. That means capacitor takes more time to charge, capacitor takes less time to charge, right? In
Yes,
such
sir.
a way, this relation is there. This you understood. As you know, temperature increases, your delay will increase, right? This
Yes.
is for less than 65 nanometer. Okay, but temperature inversion is nothing but as temperature decreases. For example, minus 40 degrees Celsius. These cells are also available in our library. Did you see that cells? Did you open that cells and check that? You have done that or not?
Yes, sir.
Please
Yes,
go
sir.
through that library cells. You won't get these libraries after coming out of this course. Understand that libraries. Almost every company has those libraries. We have given our libraries to Tech Mahindra, TCS, University Global and all. They are taking training from us. You know that? Is it clear, guys? So open those things and read it. You have time. I'm seeing so many people are not reading it. If you have read it, you would have asked some doubts in the group. People, you are very lazy. I can see that. See, right now I am telling you that you would have done synthesis for some other codes, whatever there in some textbooks. So see, it is not compulsory to understand the codes. Take some code, synthesize it, give some design constraints. You can give some design constraints, right? Yes or no?
Yes,
Yes,
sir.
sir.
Yes,
Give some design constraints, come up with your netlist, take that netlist, do it. Do floor planning up to that. You will understand. Without macros, you can do that, right? Yes or no, guys? Anybody
Yes,
has done
sir.
that up to now? No. Whatever we teach, you study that thing and go to company. Okay. See, this is not you need to do. You need to learn. You are engineers who came out of the college. Not you are not in college. If I give something like do one cell, you need to do 100 cells, 100 variations. That's how innovation comes out. Getting things, guys.
Yes, sir.
You are simply wasting your time. Afternoon full, you have time, you have access to the tool, still you are not doing it. Okay, fine. So minus 40 degrees Celsius, that means your delay increases. This is what is your temperature inversion, right? Why this happens? Yes, somebody was telling Geetika. Why this happens, Geetika?
Because of threshold voltage.
Again, you are telling threshold voltage. How threshold voltage is related to delay? Threshold voltage related to temperature. See, please understand mobility as temperature is related to mobility. Mobility means what? Electron hole pairs, right?
Sir.
Yes or no? As temperature increases, electron hole pairs increases.
Increases.
Please understand, because of that only your Vth increases and decreases. So as temperature increases, that is what is all about your current gain or something in your BJTs and all the things. You have seen that?
Yes, sir.
It's like that. The concept is like that, alpha and beta, something like that. So your mu and Vth increases or decreases, that depends. Now you know your delay is inversely proportional to your mobility. Yes or no?
Yes, sir.
Yes,
And
sir.
your delay is directly proportional to your threshold voltage, right? So if
Yes, sir.
threshold voltage increases, it takes more time to come out of the off state. If threshold voltage decreases, it takes less time to come out of the off state, right?
Yes, sir.
So the resultant effect of this decides the delay. The resultant effect of this decides the delay. But please understand, at lower nodes, what is your Vs? Is it less or more?
Less.
Less.
Less, right? Vs is less. If Vs is less, what happens to Vgs minus Vth in that ID equation?
More.
Yes.
Less.
Hey, Vs is less, man. So what happens to this? As Vs is less, Vth also becomes less, right? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
So it is square now. If it is square, it is very, very less, right? Yes or no?
Yes, sir.
Yes,
So
sir.
obviously, if it is less, what happens to ID? Less. If ID is less, what happens to delay?
More.
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 That means as temperature decreases, your delay increases like this. It's interrelated. Any doubts here? So ID reduces. Please don't talk some rubbish in between, that is waste. ID reduces. How ID reduces? ID reduces like this at lower nodes. Is this clear, guys?
The Vs is less, then Vgs will be more.
Yes, sir. That's why I told more.
It will be more.
No, I'm
VG
asking about
minus
this resultant, VGS minus VS, not only about VGS.
Sir, if VGS increases, then
In
VGS
lower
minus
technology
VGS also
mode,
increase.
VGS minus and VTH, they are very much close to each other. So that square will be more.
Square will be more. How
Yes,
square
sir.
will be more? No. See, VH is reducing, right? This is increasing, right?
Yes, sir.
So what
More.
happens to this value?
Depends on the how much variation. That means how much VDH is decreasing and how much VGS is increasing.
That depends. So see, that depends. But this value become very, very small because VS is very less, right? As VS is very less, obviously your VH will be very, very less. VGS also will become very, very less, right? This is main thing, right? Yes or no? Whatever you said for higher nodes, it is correct, but not for lower nodes, right? Guys, any doubts here? So as ID reduces, delay at lower temperature increases. So please understand, this is how temperature inversion happens. Delay decreases, sorry, delay increases here.
Sir, lower technology delay decreases.
Sorry, delay decreases. Sorry, delay decreases. Sorry.
And
Is this
ID
clear?
increases.
Temperature increases and delay decreases. Sorry. Is this clear, guys?
So then their ID must increase.
The ID also should increase. Then only delay will decrease.
Yes,
Yes.
sir.
See, please understand, ID is reducing. That means if you take your capacitor, now ID is very less. That means it takes more time to charge or less time to charge.
More.
Time to charge.
Less time.
Then
No more time.
ID
More.
is less.
More time to change. Sir.
Ha,
It
more
takes
time.
more time
More
to
time
charge.
to
If
charge.
it takes more time to charge, what happens to delay?
More.
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 Right. Yes or no?
Yes, sir.
Sir.
So that means as ID reduces, delay will increase. Delay will increase. Please understand. Is that clear, guys? Yes or no?
Yes, sir.
So this is all about your temperature inversion. Any doubts? But what happens in higher nodes, we will see. You are telling that what happens in higher nodes. See, in higher nodes, if you consider ID, VS is more, right? VS is more. So effect of VS will be less. Yes or no? But here in lower nodes, effect of VS will be more. So that means your VGS minus VS will increase here. As this increases, your ID increases here. See, at higher nodes, your mobility plays major role. Please understand.
So you are telling reverse. In higher nodes, ID will decrease.
No, see, how ID decreases, VS is more, no?
But mobility, sir, it will have more effect, and due to which temperature increases.
No. See,
ID.
that is as temperature increases in the higher nodes, your mobility decreases, right?
Yes, sir.
Yes, sir.
As your mobility decreases, what happens to delay?
Increases.
Increases. Yes or no? See,
Yes.
this is separate.
Yes, sir.
See, this is separate thing I am talking about. Is this clear?
Yes, sir.
Okay. So ID increases and decreases like this. As ID reduces, delay increases. As ID increases, delay reduces. Please understand that. Clear with that? Okay. So now we will see RC variation also. So these three things are very important: temperature, voltage, and your process. Voltage and temperature. Okay, next. So now there is something like RC variation also, right? What is this RC variations known as? Nothing but your setup violations and hold violations, right? So what is setup violation? Actually, when this violation occurs?
Data is captured at the next capture edge.
If data is
After.
coming very slow, then this occurs, right?
Yes, sir.
Is that clear? Now, hold violations is caused if data is
Very fast.
very fast. Yes or no, guys? Is this clear?
Yes, sir.
Okay. Now, how does this process affects these things? How does this process voltage and this temperature affects this?
If my process is slow,
If it is slow, fine, very good. If it is slow, what happens?
data will be coming slow.
Data will be coming slow, and voltage is less. Okay, please
Yes.
understand. Slow, voltage is less. Then temperature is more.
Temperature more.
Okay. Now, is this best case or worst case for setup?
Worst case.
Delay will
Worst
be
case.
minimum or delay will be maximum here?
Delay will be max.
Delay will be maximum. Right? This is worst case for your setup. Yes or no, guys?
Yes, sir.
And also you can take one more setup also, like slow, voltage is less again, and temperature is minus 40 now. What happens to the delay now?
Less than the previous one.
But delay is maximum.
Yes, sir. But less
Delay
than
is
the
maximum
previous.
here also. These are the worst cases for the delay. Yes or no?
Yes, sir.
So if you check for this condition, that means there is no worse than this, right? Getting things? Now, what is the best case? You will be checking hold for the best case. Hold means what? It should be fast, right? Then what about voltage? Voltage should be, which is the
High.
higher value? High, right? Then temperature should be
Temperature less.
So
less, right? Temperature should be less. Then what is this? Maximum delay or minimum delay?
Minimum delay.
Minimum delay. Please understand, the delay will be minimum. So now both can be checked in worst corners. Okay. So if I check for these scenarios, there is no need to check for the middle scenarios, right?
yes, sir.
Yes.
So generally people check for this so that in between values need not check, because your chip is working for worst and best, right? Why you need to check for in between then? But still we will check for some typical conditions also. Why people check for typical this thing? Why these cells are there then? To analyze power consumption. Getting things? Is this clear?
Yes, sir.
So this is all about your PVT corners. For example, in the last class, I have shown you that. Okay, 1 minute, I'll show you that again. So if you have some mode like this, okay, and you have something like process, voltage, and some temperature, then you have some RC variations also, right? So your delay is all about cell delay plus net delay,
Net delay.
right? So your cell delay comes from your library and your net delay comes from where?
TLU.
TLU plus file. Very good, right? Yes or no?
Yes.
Now I can take some mode here. See, there are different modes. I'll just explain that later. Functional mode, like scan mode, at speed mode, okay, and DFT mode. So generally, see, functional mode is nothing but functionality mode. Scan is all about that design for testability and all. At speed means I will be checking your this thing at the speed it is operating, at the same frequency it is operating. Okay, and DFT mode is also, again, they will be operating at some 50% of the clock or something like that. Okay, don't bother about that. So just we'll see there are some modes, functional mode, scan mode. At speed is nothing but I will be operating at the speed of the same frequency. Okay, so now if you take some functional mode, generally we check at functional mode, we will see for some setup. Okay, so for example, I'll take process as slow and voltage as very less, 0.9, because I have taken 1.1 to some 0.9 volts, right? The variation of voltage. Is this clear, guys?
Yes, sir.
So now temperature, 125 degrees, highest temperature. So obviously RC worst and C worst. Generally inductor won't affect much in the delay. It affects only the bounce of the voltage. So now I'll take this case. In this case, is your delay worst or best? In the first case, this case.
Worst.
Delay is worst. You will be getting worse than this?
No, sir.
No, this is the worst scenario, right? Yes or no?
Yes, sir.
Now, second case I'll check. There is one more case also for minus 40 degrees also, right? Yes or no? RC worst and C worst. So these are the two worst cases, right? Depending upon the temperature variation. Is this clear, guys? Other than these two cases, you will be getting any worst case?
No, sir.
No chance, right? Yes or no? Now, what about best case? That will be for hold, right? So same functional I will take. So what should be the process for best?
Fast.
Right? So the delay will be less. Good timing, right? Violations will be less. Then what about voltage? It should be
0.1.
highest value, right? Then if Vs is more, you know that delay is less because your current will be more, right? Which is flowing from source to load. Yes or no?
Yes. Yes, sir.
Yes. So what about temperature now? I'll check for minus 40 degrees, right? Now I'll give RC best and C best. This is the best case. Yes or no? So
Yes.
worst case and best case. If my design is working for this worst and best cases, in between, this is my worst, this is my best. In between, you need to check any values in between. Is it necessary?
No.
No. So like this, we create multi-mode, multi-corner design. Any doubts? Oh, okay. I think we have some more.
Minus
time.
40.
Yeah.
Sir, minus 40 has more delay, no temperature inversion takes place, no?
Minus
Instead of
40.
Instead of minus 40, we have to use the 25 or In between 0 to 20. Then only the temperature, the delay will decrease. And whole
See, voltage is more here.
Okay.
Okay, voltage is more here.
Hmm.
So what about temperature then?
Temperature should be low now.
See, at lower nodes, voltage will be very less due to temperature. But the voltage is more here, no?
That's why we are considering minus 40 degrees.
That's why I am considering minus 40 degrees.
Okay, sir.
Getting things. Check for other things also and tell me. See, you have some cells in your library now.
Yes, sir.
Use these cells.
I
Synthesize.
use it, sir.
You
Yes,
use.
sir, I did, sir.
What is the worst and best cases you got? Tomorrow, everybody get me those things. We will compare there. Okay? Practically, we will see. What do you say?
Okay, sir.
So, how many people will take this task then? There are 20 people, right? Who are those people? Okay. Yeah. So, we will assign now. Okay. Among Sushmita, Binay, and Divya, which case you will take to analyze results? I need sanity checks tomorrow for these libraries. Sushmita, Amog, Binay, and Divya. Yes? Yes, which case you will take to show me the sanity checks for that? Library, lib. Guys,
Slow, sir.
Slow. Okay. So please divide yourself and do and get me. We will compare and we will see which has worst and which has best. Okay. Then you will understand things. Is that clear, guys? We'll compare all the things, power dissipation, timing, everything we will see. Okay. Fine. This is all about your corners. Any doubts? Any doubts, guys? See, there are so many possible options here. Okay. Almost there are 468. How do you get this 468? Can anyone tell me? There are so many libraries, right? How many possible options you will be getting here? How do you know that how many possible options? Because you can see in P you have 3: slow, fast, and typical, right? Yes or no?
Yes, sir.
Yes,
In
sir.
voltage also you have some variations. I'll take 3. Okay. In temperature also we have some variations like 25 degrees, minus 40, 25. We'll take minimum as 3. Okay. 3. Then you have something known as RC best, RC worst, RC nominal, and C best, C worst, C nominal. How many options you have here again? 6. Yes or no?
Yes, sir.
Yes, sir.
So if you multiply all these things, how many options you are getting here? And there are again functional modes. There are 4 functional modes. If you take that 4 also into consideration. Okay, now tell me how many possible options you will be getting here?
48.
Just
648.
48. 3
648.
into 3,
48, sir.
4 into 6, 3 into 3, 3 into 3, then 4 into 6 total.
48, sir.
648.
648, right? So in this 648, this is the worst case and this is the best case. Check it. Is that clear, guys?
Yes.
Clear with that? So if you check for the worst and best, you need no need to check in between. You will come to know this by experience. Please do it. Okay. Fine. Okay. Please open your putty and we will go to. Okay. This is multi-mode, multi-corner. I'll explain this again. How to run that also. Don't worry, because that is again just sourcing that. That's it. But you should understand all these things. Okay. Yeah. So now we'll go to floor planning now. So please open that whatever file we have done in the previous class. What is that we have done?
DTMF.
DTMF, very good. So we have created all these things, lib, reports. Anybody has any doubts in this creating things? Please let me know now itself. As we proceed, we'll be fast now. Yes. Yes. Anybody has any doubts? Okay, so I'll just invoke the tool now, tcsh, then ICC2 shell. Okay, output file I'll be using. Okay, I'll be using now FP floor plan dot TCL. Sorry, log. Is this clear, guys? Any doubts here? You should reply, man.
No,
Are you?
No, sir.
No, yeah. So invoke the tool, open one xterm also, so that I'll ask you to open .tex file also, netlist also, and I'll ask you where that information is present, please fetch it. So you should be ready to fetch that information now for me. So now, what is the procedure to open the lib, whatever you have done? First, what is the step after doing invoking the tool? Yeah.
Use command open lib.
Open lib, open underscore lib, right?
Yes, sir.
You are stored in lib, right?
DTMF.
DTMF underscore lib. That is user defined. So the
Yes.
names can be different. Okay, I have given that name. I'm using that name because I've created lib by using that name. So you can see now NDMs. NDMs is nothing but, what is that NDM? New data model, which has
Data
lib
model.
and left. Lib and left. Is that clear?
Yes, sir.
Up to this, anybody has any doubts? Next, what do I do next?
Open block.
Open blocks.
List blocks.
List blocks. Good. So open block also you can do. If you want to list, you can list also blocks, whatever blocks you have done. So the two blocks I have done already, import done design or sanity checks. I didn't do any change in sanity checks, right? I have just saved it as like that. Okay. Yes or no, guys?
So
Now go to import design. How to open that?
open block import. Done.
Open
Underscore block.
underscore block. This is the procedure to open the tool, and you need to
Important.
close. If
Import
you
underscore
don't
done.
open and close properly, then it will be locked. Anybody face that locking of that thing anytime?
No, sir.
No?
No.
I'll show you now. Open underscore block. Okay, what is that block name? Import done.
Import done.
Okay.
Import done.
I opened it, start GUI. See what I will do now, I'll just exit this. Or I'll just cancel this. Gone. Did you see that? I didn't close it properly, right?
Yes, sir.
Yes, sir.
Please, you people don't close. Just I need to show you. Okay. If this happens sometime, power loss or something, that time you abruptly it comes out, you need to take care of that. So CD that, what is that? Yeah, November 3, right? Okay. Okay. So DTMF, I am into this now. Okay, LS. Okay, fine. So I'll be invoking now the tool. See, whenever you don't get that, you need to invoke the shell. Okay. When you press tab, it should come like this. Is this clear, guys? Any doubts?
Yes, sir.
Okay, fine. So logs, I am fp.log, that will be replaced now, and I'll be invoking the tool. Okay. Is this clear, guys? Now we will see what happened actually, how the block will be locked. I'll just go to xterm and I'll show you now. Okay. So if something is blocked or locked, sorry, locked, you can see I'll do ls minus lrth. Yeah. You can see some file here. No, you need to go to lib. Sorry, cd libs. Okay, what is your lib?
DTMF
DTMF underscore lib. Okay. Now if you do ls, you can see, right? LS minus LRTH. You can see something known as here lib NDM master lock.
Yes, sir.
You can see that. So you will be getting this. You cannot open the libraries. It will throw error when you invoke that. Okay. So before that, you should open lock for this. So if you want to open lock, you need to just do RM minus RF. This is how to remove the lock. RM minus RF. Please write down this. Have a note. RM minus RF. So what is that? Lib dot NDM. Lib dot NDM. You can press tab. Okay. Is this clear, guys? Before opening the block, you need to do this. If you do this, now you can see LS minus LRTH. That lock has been removed. Is this clear? Opened. Getting things?
Yes, sir.
Anybody has any doubt? Just have a note of this. Something like this. Oh, sorry. So many things I have used already. Any doubts, guys? What is this? I'm getting full history. I need to show you again. So open the library and you should open the lock. Okay. By using this command, RM minus RF, whatever name it is, and you can open this. Everybody got this? Have a note. Okay. Okay. I'll go back to this again. Okay. So I'll be invoking the tool now. How to invoke the tool? You know already, right? What should I do? Open lib, open underscore lib, right? It will be lib. Then in libs, you have DTMF lib. It will be loading now. If not this, you will get an error here. Okay. Is this clear, guys?
Yes, sir.
And please check what are the libraries it is loading also. You can see SRAM, PLL and all the things, right? So please open your netlist parallelly and see how many SRAMs are there, how many PLLs are there in your design. Netlist, open the netlist fast. I'll ask you somebody to share and I'll ask you how many SRAMs are there, how many macros are there. Just open that. See, make it as a habit so that it will be very easy for you. Open underscore block. I am opening the import done. Okay. Now start GUI. Any doubts up to this? Please let me know. Up to GUI. Everybody has done up to this? Clarity? You got some clarity? Guys, please reply, no? You're using your microphones, your earphones, right? Yeah. Everybody got this? I'll just show you what is floor planning today. Then after Utkarsh explaining about that macros and all the things, we'll do that in the subsequent classes. No hurry. Everybody got up to this? Geetika, Sushmita, Sudhir.
Yes, sir.
Yes,
Are you
sir.
there? People are sleeping.
No, sir.
No. Good. Do it. Do with me. Okay. So this, everybody got this screen? If anybody has any problem, please let me know. Some problem with this. Yeah. Okay. Doc. Yeah, how to remove this, man? Can I hide this? Hide names of. Ah, good. Yes. Everybody got this?
Yes, sir.
So how many macros do you have in this design? That is what is my question.
6.
6. How do you tell that 6? How do you tell that, man? I cannot see 6 here, no?
We can separate them.
You can separate. See, if there are many macros, you will be separating and seeing them. You cannot do that, right?
Yes, sir.
Yes, then how do you get that? What is the command? Report underscore some stats, design stats. Where do you get design stats? report underscore design minus all, right? Yes or no? Getting things, guys? So you can see here the information about your design is present here. Please go and see what is there in this. So you can see that stats. Okay. Getting things? Total number of standard cells. How many are there? 863. Total number of don't use library cells. Somebody has given library cells should not be used. Somewhere we have used don't touch, don't use command, right? Do you remember that? For X0. Then total number of buffers, inverters, flip-flops, latches, ICGs. What do you mean by ICGs?
Integrated gate.
Yes. Now you can see total leaf cells. But where is macro information? And you can see the area. Write down this area in next to you. I'll ask something about this again. So area is this. The core area will be this. Okay. Then standard cells area is this. You can see something hard macros. How many are there? 6. So the macros is occupying so much of space here. 85% of the space. For floor planning, this data is very important to me. Getting things, guys? Now there are 6 macros. If you want, you open your lib file and check. No, sorry, netlist file. So where is that netlist file? Anybody can tell me how to open that? Have you any idea? Where is that netlist?
DTMF.
Inputs, right?
Yes.
So I'll go to your this thing only where I have saved. Okay, home PDF, right? This is your path, right? So ls cd pnr. I have created subfolder by name pnr. In that pnr, I have given DTMF. Okay, in this DTMF, I have inputs. In these inputs, I have what? What is the name of the inputs?
Receiver code.
Receiver core, right? So I'll do gvim and I'll open that DTMF receiver core, right? So in this, now you can check your top module and all the things, right? Yes or no? So how to check that? What is your design name actually? That is what is your top module. What is your design name in data preparation? What is your design name?
DTMF receiver.
DTMF receiver, something like this, right? You can see I am able to find this module now. What is this module? DTMF receiver core. This is your top module. Is that clear, guys?
Yes, sir.
Yes, sir.
So here the complete information is there. Pins also. How many pins are there in your design? How to get that? Go to again that same command and see how many pins are there here. Tell me how many pins are there in your design. Fast. I need answers here. Go through that. Then what did you do in the sanity checks then? I said you to note down something, right? How many pins are there? Still I didn't get answer.
Get pins.
Get pins you will do. Do it and tell me how many pins are there fast. In this you don't have any pin information?
Port and pin information is there
410.
here.
Okay. Get underscore. Now what is the command? You to get the ports and pins?
Get port.
Get underscore ports, right? Okay, we'll see how many ports are there. So I need count. How to get this?
Size of
67
collection.
ports are there total.
How do you get that?
So size of collection, then
Size of collection. Good. Size of collection. Right? Yes or no?
Yes, sir.
Size of collection. What should I give in the brackets?
Get pins.
get pins.
Get ports, right?
Port.
Yeah, get ports. You can tab and you can check. You will get some information. Okay. 67 ports are there. So if you go to your netlist and see, you will be having that 67 ports here. Okay. You can see that output is 8-bit, then output is 16-bit. If you count all those things, it will be 67 ports. This is, guys, is this clear? Input, output, and in-out ports also will be there. You can see this is out, data in, scan out, then input ports are this, right? Digit output is this, and so on. Getting things, guys? Yes or no?
So do it once.
Yes?
Once again do it.
Once again? This thing?
Yes, sir.
Yeah, you can see here. Size of collection, get ports. Very important, because we will be after doing floor planning, first thing what we do is fixing the ports, placing the ports and fixing the ports. Before that, you need to know how many ports are there, right? And where to place them. Which are input ports, which are output ports. Is this clear, guys? There is one more command to see, get underscore cells. What does this do? What are this? What are these cells?
Displays cell name.
Which cells? What are these cells?
The standard cells and macros.
Standard cells? No, it's not standard cells.
Instances.
Instances, right? So there are 35 instances. So just open your VG file and check these things. So these are macros. You can see the macros now. SRAM. You can see here. 1, 2, 3, 4, 5 macros. Then you have some standard cells. You can see then instantiations, PLL instantiation, then some test control instantiation, then this instantiation, data sample instantiation, then TDSP core instantiation, and so on, right? Can you see this? So these are the cells which are present in our design. So if you want number of cells to know, what is the command you need to give? Yes. You can have
Get cells.
Get
here.
cells.
Okay. 35 cells are there. So 35 instantiations are there. Okay, getting things, guys? Any doubts? This is your top module. So these are your standard cells which they got from your library, picked from your library. So you can see this is your top module. Going up, you can see all other sub modules. For DMA sub module, then you have for arbitrary, then you have some sub modules, and go on, so on, like this. Is this clear? Modules, different modules. Is this clear, guys?
Yes, sir.
Okay, this is what is the information you need to have as a PD engineer. If not, it is very difficult. So next, go to this IC compiler. So there are so many macros like this. So you can get what is the number of macros and all the things. Now, if you want to move these macros, just click on this and use M in your keyboard. If you use M, you can move that macro. You can move that macro.
Hello, sir.
Yes.
Sir, I have not completed the bracket and I have got question mark in the putty.
You got some question mark?
Yes, sir.
Control C. It came out.
It came out of the ICC.
It came out of the. Okay, again invoke. I'll wait for you. Don't worry. Any doubts, guys, up to this? Anybody has any doubts, please let me know. before going to floor planning, you should know how many ports you have in your design, as well as you need to know how many macros you have in your design. Yes. Can you drag it and check it like this? Are you able to do that? So how many macros are there?
6.
I'm able to see only 5 here. There is one more here, right? You can see. So if you want to fit page, use F. F. Are you able to do that? And escape. It will come out of that selecting mode. So if you want to select, you need to use this arrow mark. Okay. Then only you can select in this tool. Like this. Use M to move this. Anybody has any doubts? Please let me know. Done? Oh, I think it's time up, I think. Okay. No problem. Just give me 2 more minutes. I'll close this session. The next class we will be seeing complete floor planning. Don't worry. Any doubts, guys? Up to this, anybody has any doubts? Please let me know. See here, where are the ports? Can anybody show me where are the ports? Where are the ports and standard cells in this design? Anybody has any idea where to find that? So I can do undo also here, Control Z. I'm doing that. Yes, done. So you can see there is a zoom option and you can zoom here. You have a zoom option. You are able to select that. Guys, please reply. Sushmita?
Yes,
Sudhir?
sir.
Yeah, are you there? Yeah, Vinay, Tarun. I need to be familiar with other persons. Sanat, are you there, man? Sanat? Sharun? Rekha? Ravi Kiran? Ravi Kiran?
Yes,
Oh,
sir. Yes, sir.
are you able to see this?
Yes, sir.
You can zoom like this. So what are these known as?
Standard cells.
Standard cells. Please understand these are the standard cells which are present in your design. What is this? What is this known as? This dot you can see?
Yes, sir.
What is this? Pins. The pins in your design. Just use fit to page F. It will come back. So your standard cells and pins are below here. Select this zoom option. You can zoom and see your macros, your pins, and your standard cells. Anybody has any doubts up to this? So first you identify what all the things are there here. Any doubts, guys? Any doubts?
No, sir.
Okay. I'll just give introduction to floor planning today and I'll stop it. Okay. So the first step is to create floor plan. So why I need to do that? Yes, guys.
So that there will be no congestion.
No congestion, no, right? I need to design a chip of this area as minimum as possible, right? So how do you decide the core utilization of your chip? Depending upon what? I need to make a floor plan. For that, I need to design some shape, right? Yes or no?
Yes.
How do I design the core utilization of your design? My question is simple and straightforward.
Depending on input and output.
Depending upon your standard cells macros, right? Yes or no? Depending upon that, I will design my core, right? That's what Utkasha said you in the class, right? Yes or no, guys?
Yes, sir.
And blockages also. Right now, you don't know what is about blockages. We'll see it later. But depending upon macros, so macros plus standard cells. So you can see the area of macros and standard cells. What is the area of macros and standard cells? We have seen that somewhere, right? What is that? You can see this. What is the area, total area? This is the total area of your cells. So depending upon that, you need to design your core. Okay? Getting things?
Yes, sir.
So now go to ICC compiler. The first step is to create floor plan. Go to task assistant. You can see something like design planning. I'll repeat it again. If you want, you can go to task, design planning, or you can click on task assistant also. Go to design planning. Okay, sorry, escape. If you want to come out of this, just escape. Okay, task, design planning. You can see something right side, right? Floor plan preparation, overview, and floor plan initialization, right? So double click on floor plan initialization. You will be getting a window. Did you get that? I'll just show you what is floor plan today and I'll leave you another 2 more minutes. Just give me some time. Yeah. Yes. Everybody got this window?
Yes, sir.
I need reply from everybody.
Yes, sir.
Now here you can see core area and die area. So what is the difference between core area and die area?
Area is used for
Macros are placed on core area.
Ports are placed on the core area. Okay. So I'll just open that PPTs to show you. I hope you have that idea, right?
core area is for placing standard cells.
So you can see this, you have seen this PPT, you can see this is what is your die area, right? And this is what is your core area. Is this clear, guys? So core area is the area where we will be placing our macros and standard cells, right? Clear
Yes.
or not? Okay, fine. So I'll go back to this now. So now you can see I'll select core area. And you have something like template and custom, something rectangle, something like this. Okay. And something core utilization is there. What is this known as core utilization? I said you just now, what is that core utilization? Guys, understand these things. Just
Standard cells and macros.
Yeah. So it is nothing but your standard cells plus macros. So for example, if your core utilization is 1, what happens? Here something 0.7 something is there. How does this affect your design?
70% of the
So that
core area
means
is used.
I am allocating 70% to your macros and standard cells. Is that clear? Rest 30% I am allocating for the routing resources. Is that clear, guys? That is the meaning of core utilization. I cannot give 1 here. If I give 1, what is the meaning of that?
Total 100% is
100% I am giving for only standard cells and macros. I will be placing that. Then where is the place for routing and blockages, special cells? So many other things will come in placement also, right? So where is the place for that? There is no place for that, right? So I cannot give 100%. Is this clear, guys?
Yes, sir.
yes, sir.
So for example, I'll ask you one question now. If standard cells plus macros, the area is 1000 micron square. For example, my core utilization is 50%. Then what is the area occupied by them? What is the core utilization?
500 microns.
500.
Huh?
500.
Please understand. Standard cells plus macros area is 1000 micron square area. So I need to use core utilization as 50%.
2000.
2000 micron square, right? How it is 500? How it is 2000?
Because your standard cells and macros must be at 50% of your core area.
Yes.
So it must be double the
It
standard
should be
cells and macros.
double, right? Yes or no? So if it is 50% is my core utilization, are you able to understand, guys? I'll just write it.
Yes, sir.
Okay, 1 minute. So, for example, the area of my standard cells and macros plus blockages. Okay, standard cells plus macros plus blockages. The area of this is 1000 micron square. So now my core utilization should be 50%. So if it is 50%, it should be 2000 micron square, right? Yes or no?
Yes, sir.
For example, now other person is designing by taking 75% core utilization. So if it is core utilization is 75%, what is the area he is using for that?
1250.
1250, I think, right? Just do calculation and tell me, man. If it is 75%, what should be the core utilization area? If it is 1, what is the core utilization area? I think for this you can tell.
1333 something.
For this 100%. Okay, for 100%, what is the core utilization area? It should be 1000 micron square only, right? Yes or no? For 50%, it should be
2000.
2000. For 75%, it should be, calculate and tell me.
1333.
Something like that, right? So now which core 1333 something he said. So which is better now? Who is using less area here? This is better, or this is better, or this is better? Who is consuming less area here?
1033.
1033, right? So he has better design than me. But this should meet all other things also, like power, area he has met, timing also. Violations should be less. Is that clear, guys? Getting things?
Yes, sir.
So this is how the core utilization will affect your design. Okay, so just understand. Now I'll show you what is that core utilization, and I'll stop here. So now if you see here, there is that window, task assistant. So now I'll go to core utilization of some 0.65, 65%. So how do you choose this? How do you choose this? So I'll start with 0.5 and I'll do all this design up to routing, and I'll check. If I'm getting better design, I'll confine with that. If not, I'll redo it again by taking some other core utilization values. Is that clear, guys? Getting things. Now you can see preview here. You can see preview here. Just use that preview. You can see some shapes here, right? So go to sides now. So these are the sides 1, 2, 3, and 4. So I'll give sides now as some 1 and as some 0.65. What is this known as? 1 and 0.65? Dimensions of the sides. So you can see I can change the dimensions of the core now. Can you see this?
Yes, sir.
You are getting things, guys.
Yes, sir.
So he said that your core can be rectangular, L shape, T shape, and U shape, any shape. So if you see rectangle doesn't have any orientation, that's why you are not able to see anything. But if I go to L shape and do preview, you can see, okay, I'll remove this. And preview, you can see some L shape here.
Yes, sir.
Like that, you can see west facing, east, like your site only, nothing different. Okay, see, you have different shapes here. You can select any shape like this. Please understand. Okay. So for rectangle, you don't have any other orientations because rectangle has only height and so that length and width. So I'll be giving some 1 and 0.65. This decides the length of that 1 and 2 sides. Preview, if you do, you can see this. Any doubts, guys? Is this clear? So this is your core area. Then you have something known as die boundary, right? Die area and core area. Yes or no?
Yes, sir.
Okay, with this I'll stop. Okay, die area is nothing but core and die. Just now I have shown you. For example, uniform. Uniform means all the sides. If I give some 5 here, 5 microns, the die area also you can see here. You can see core area and die area with different colors here.
Yes, sir.
With a distance of 5 microns like this. So if you want different sides, different lengths and heights, you can give vertical and horizontal. So how to choose this vertical, horizontal? That depends upon your tile size. What is your tile size in this design? Unit tile, height and width. 1.672 or something 0.152, right? Yes or no, guys? I think you people are drained today. Okay, no problem. This is how you can choose core and die area. So we will continue this in the next class. Okay. Shall I stop here?
Yes, sir.
Okay. Okay then. Thank you. So how to close the shell, guys? Don't close just like that. How to close the shell? What is the command?
Close,
First
lid.
command. What is the first command you need to do? Close.
Close
GUI.
Start close GUI first. So stop GUI. Then
Close block or close lid.
close lib or block.
Lid.
Blocks.
Blocks. I am not saving anything because I have not done anything here today. Okay. Close blocks. Then close libs. You can use -F to force close. Okay. So next class we'll be seeing these things. Okay. Thank you. Anybody has any doubts? Please let me know. Anybody has any doubts? Can you mute? Somebody is unmuted. A lot of disturbance. Yeah. Anybody has any doubts? Okay then. Thank you. So in the next class, we'll be seeing floor planning. Don't worry about that. Floor planning and plinth placement. Any doubts up to this? Okay then. Thank you.
Thank you, sir.
Thank you, sir.
Yes, sir.
I'll end the meeting then.
Thank you.
Thank you, sir.